Okay, I want to start off by just showing this. My good friend from NASA and the European Space Agency, Pedro, which I highlighted him on a video just recently, he had all his papers laid out and he finally burnt them all because he was done. And he's retired now. But he still gets all these things from the NASA and from European Space Agency, from all the vendors and all that stuff, because he's on the list. And they're always short. Look, 1 minute and 24 seconds. This is solar cycle as seen from space. Well, let's see what it says. Watch. And then after they're done, I will comment. Cosmic rhythm. I go back a long way with this solar maximum, solar minimum. Now, I am going to explain as they go through exactly what's happening, because they don't realize the ether of space, which we are scrubbing through, heats the sun, it heats us over and over and over. Now, the sun is discharging, it appears, every 11 years, and it goes into that minimum cycle. And I believe it discharges, and I have found something in ancient text that looks like it's showing it discharges. We'll go into that in a minute, but I do want to show that we are loaded with ether. As I always said in the ancient days, we've changed everything, and now we don't even understand how things fall to the earth, called gravity. We are scrubbing through the particles that are light, which are coming from the sun to us. Obviously, they hit us and burn us. They hit solar cells and cause electrons to bump into moving into conduction. It's insane to think there's nothing out there. Absolutely insanity. We scrub through that. The sun scrubs through it. The sun is gigantic. Every 11 years, it gets overcharged and it discharges. We are overcharged now, and I don't know what's going to happen, but we are way overcharged. That's what it means to be global warming, is every extra electron, and we keep scrubbing through them. We could collect them. They don't just go back into space and say, I'll see you later, have a nice day. We are burning all kinds of things that were collected into chunks, and now we've exploded them into gigantic, enormous regions. And it may even affect the Schumann resonance. I'm not sure. But the Schumann resonance, we're going to go into that in a second, because there's different layers, 7 of them, that surround the Earth. And here's what happens. I'm going to explain it to you right on here. Let's say that's the Earth. We have all our atmosphere around the Earth. Everybody knows that. And they call them the troposphere, the stratosphere, whatever, magnetosphere, ionosphere, so forth. Now, what that is, these are different layers of the Schumann resonance. And there's 7 different layers, and there's 7 different layers of groups in the periodic chart. And I believe these all relate to this. And it's the frequency of the vibration. And you say, why is there a frequency of the vibration? Here's the reason, is as it scrubs with our electrons, and electrons are like, we've got photons and electrons out here. All right, this is the one that pushes. That doesn't do anything. That's the dark matter. It does nothing. But it's got to be with one of these. And we're all going this way. And as that little red particle and this little red particle scrape against the red particles and the ones that are out here, it's push to shove. It overheats it. And those particles come into us because the sun is shooting them at us. We're scrubbing through them. They bounce down to the next layer. It tries to push back. that pushes, when it tries to push back, it pushes down to the next layer. That tries to push back, that pushes down. I'll show you on the big board in a second because I got to erase it. After all that work, it's going to get erased. But that's what's going on. It's push to shove, push to shove, push to shove, push to shove, and then the Earth absorbs it. And this layer is 7.83 hertz. And guess what our heart rate is? 7.83 hertz. And that's because we are pulsating from the electrical discharge. It's electrical discharge. It's collection of electrons, discharge, collection, discharge, collection, discharge, collection, discharge. Just as it is with the sun, only the sun is 11 years. We're every 7.83 hertz. Collects, discharges, collects, discharges. And now, we are so over-collected in our atmosphere, and the surface usually will take them. And at one time, I guess everything was balanced and it accepted them, and maybe it would have stayed that way. I have no idea, but right now it's not balanced, and it does not want any more. So that creates heat, dryness, fires, turbulence in the atmosphere. He said, get away, get away, get away. And they actually now have blue jets and red sprites electricity trying to get out of the Earth, not going into it, get out. Used to be lightning. I never saw them going north. Well, now they go up. Some of them. I mean, not a lot, but it's pretty obvious now. Okay, mes amis, it's a sad day at Mud Fossil University. The board, she will be erased shortly. Now, electron flood theory, I think everybody's seen that or knows about. I hope you do. If not, well, you should be able to follow it. I've been talking about it a lot. Now, it says that here's the Earth. Earth is here. Remember I talked about the 7 zones. I'm not showing all 7 of them, but there's 7 zones of Schumann frequency where there's discharge zones. Now, out here is what they call the vacuum of space. It's not a vacuum, absolutely not a vacuum. The particles that are out there are electrons that are shot out from the sun. The sun is shooting all these particles, and they shoot out them in photons that are these little blocks I've shown 100 bazillion times, and in actual pictures, not just representations. Now, we are scrubbing through those. We absolutely know this because it's the ionosphere. It's a very charged region. Why is it so charged? Why is it thousands of degrees out here? It's hotter than hell because we are scrubbing against these particles that are trying to bash into our particles that are also energetic. They push each other away from each other and they create light. That's what light is. Anytime you see light, it's push to shove. 100%, zero. It's always, 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 always the energy between 2 particles. When you see something glow, the one that's the white one glows. 100% every single time. Now, sometime you'll see them glow when it's molecular interaction, electrons bonding with other electrons and letting go of an electron, and then you'll see it glow, absolutely. That's chemistry. Then there's smashing them together where they just smash out an electron as light. That's a whole different issue. So we're going to be talking about this is smashing a particle into another particle, emitting light. If I was to take a bioluminescent particle and it would, fish light up. Everybody knows that stuff. That's low. That's not a smash. Nobody's smashing that thing. It's chemistry working with another piece of chemistry to make, something. I'm not exactly sure of how every interaction works, but it is breaking a bond, releasing electrons. Electrons are the only thing that glow, and electrons are released and they pump up big like that. When you do from water, let's just take water. When you take water and turn it into steam, how much bigger do you think it gets? 1,700 times, I believe. Now, which water actually is like a lot bigger than that. But, as far as electrons go, because every electron In hydrogen, there's 1,837 electrons. So hydrogen, just one hydrogen atom is 1,837 times bigger than we thought before. So 1,700 times bigger steam from water is not such a big stretch at all. And we know that. You boil it up and it explodes. And when those little bubbles go on the bottom of the pot, when you take a pot of water, you put on there, you heat it up. I don't care what you use. If you use, a gas grill, or you use electric oven or whatever, electric stove, you're going to see little, first of all, nothing happens. You hear it go, well, that's everything sort of shifting a little bit. And then you will see the water, if you really pay close attention to it, you'll see it sort of get almost cloudy looking. And I have stuff of bioluminescence and sonoluminescence inside of water. It will blow your mind. And there's one of these cavitator discs they found. They have no idea what it does. And it has a cavitation thing like this. And I believe they use that to create cavities in the water. And if you create a cavity in the water and you shine light into that cavity, when it collapses, it crushes every electron in that light. The light is literally electrons when it becomes crushed. And I can show you this, and I will show you this, and it'll blow your freaking mind. Now, here's where it heats up like hell. That's the ionosphere. The magnetosphere is the reason it creates magnetism there. It's all falls into place with electron flood theory. The white ones are the pushers. Push against white ones down here. They try to push back. So push to shove, and then this one pushes these. Then that one pushes this one, push to shove, push to shove, push to shove. And then the Earth is supposed to suck them in. Well, if the Earth has taken so many that it really doesn't want anymore. That's why we get these sprites and these blue jets. And you can see them going straight up. I've shown that 1,000,000 times. And you look at them, you'll see there's an extreme pulse going up like this, extreme, in several different locations. And then they'll trickle back down. And this will glow like crazy, this area. And it just can't take any more electrons, so they try to get back down again. But originally they said, get out of here, I want to go down. They said, no, you can't, go up. When you build up enough electricity here, it's got to do something. And they've always talked about these, I forget what you call them, these balls, these little balls that glow, whatever they call them. They're ball lightning, I guess it is. Yeah, ball lightning. That's where it's having a hard time going this way and having a hard time going that way. It's sort of stuck in the middle. There's a whole batch of electrons, they can't get anywhere. And I've seen them actually on railroad tracks, following the railroad tracks and a train. Where it's, I'm telling you, there's things that we just have no clue about. Now, we're going to go into the push to shove and the no interaction, because this is literally dark matter. Have no interaction whatsoever on concussion. They get out of the way, the white ones explode like a bomb, and that's what creates light and heat and energy. And these are dark matter, really. And they are also gravity. And they also exceed the number of these, they say. Now, it works for me for them to be gravity. It works exactly perfect in the electron flood theory, because the dark matter goes to the center, and that's the dark matter. And then you see all the white glowing on the outside, which is the energetic particles. And I'll show you. It's so obvious, it's unbelievable. All right, this guy's from Yale. Now I tried to contact him, but I didn't hear back from him. Anyway, here goes.
So this is a very exciting day for me, because today we're going to start quantum mechanics, and that's all we'll do till the end of the term. Now, I got bad news and good news. The bad news is that it's a subject that's kind of hard to follow intuitively, and the good news is that nobody can follow it intuitively.
And he goes on to tell him, I'm just going to tell you what to say, and you say what I tell you. Nobody understands how it works, but this is what we're saying, so if you want to be smart, you say the same thing. I would have a hard time because I did. I had a hell of a time. Okay, this is a great video here. This is by Pecos Hank. And it's red sprites and blue jets explained, and they're new discoveries because we are overcharged. Once you overcharge, you start to emit sparks, literally is what they are. Now listen to this.
Transient luminous events date back several centuries. It wasn't until 19...
Now they talk about transient luminescent events. Well, yes, but not this type of transient luminescent events. This is different. I don't think they've ever shown these particular ones. They do show interactions with dense particles in our atmosphere that we are sweeping through. So there's no question that we could hit a ton of microparticles and have all kinds of lights in the air. Yes, no question whatsoever, but not this.
1989 that the first ones were accidentally caught on camera.
Yeah, see, 1989.
Years after discovery, they were named sprites for their spirit-like nature. In a recent video, we showed how one lightning flash can abruptly change the electric field, triggering a secondary flash in a sort of domino effect.
You see how they're showing them in a layer? That's what happens. You're inside of a zone that's going to either accept them or reject them. And if it has too many, it's going to have to come out. Now, where are they going to go? Normally, bzzz, right to Earth. Lightning. You get that thunderstorm and everything starts boiling and all that because you're just electrons. And they start to really vaporize the water molecules that are in the air. And so anyway, you get all that turbulence, and then poof, it discharges the ground. Well, now the ground is not so receptive, and that's when you get these sprites. Now also the blue jets. Blue jets are higher frequency.
Sprites are also initiated by a large electric field change that occurs during a massive horizontally extensive lightning strike far below. These parent flashes transfer huge amounts of charge and are almost always positive in polarity, meaning that the Earth rapidly gains a net positive charge from the strike. But pools of positive charge near the tops of thunderstorm complexes also change, abruptly gaining negative charge. This suddenly creates a powerful electric field between the tops of thunderstorms and a high concentration of positively charged ions existing 100 kilometers or so up into the lower ionosphere. It's this new imbalance that can initiate the sprite.
Okay, it's push to shove. I understand what they're saying. However, I don't 100% agree with that. I believe that this begins to interact more and more and more, and then you can even have a region in there that's over mountains or over other very warm atmosphere that is already charging this layer, and then we hit a little extra coming in, and then they charge this layer with particles. Now, are they going to go down or are they going to go back up? Mostly, this is already pushing up these particles so that they can't come down. So you end up with a pile of them right here, and then they try to go up and they can't. And then they literally explode as they hit the layer above them.
On June 22nd, 2019,
push up and then they push back down. Now listen to this.
Paul was documenting sprite activity over a thunderstorm, while I simultaneously documented their parent lightning activity under the thunderstorm.
Boom, boom. Whoa, whoa, whoa. Yeah, right there. Did you get a sprite with it?
Okay, now listen to watch what happens now. My story is that the Earth eventually will take what it has to take if nobody else will take it. And I believe that's what's happened here. It tried to go up, couldn't get up, went back down, and that took it.
That's his right.
Oh, no way!
Yeah, man.
Boom!
There.
All right, let's see if we can run this at like a zillion times slower than it's supposed to be. Let's go down here. Whoops, I don't want to do that. Here we go. Now, let's go just a hair back here. All right, they're driving down the road. Boom. Okay, now let's stop it. Whoops. Oh, okay, here's what's going on here. I got this on real slow. Something went wrong just a second ago, but we're back on here. Now, I'm going to go real slow. This guy is taking shots looking for red sprites or whatever he's looking for. This guy's driving down the road, and you're going to see down here he's on the road, and you see this will light up, and then you'll see the interaction from the people, other people that were watching at the same time. So here goes. Boom. Okay, so we got a little action going on up here. This guy is trying to film whatever he's filming. Now, here we go. Watch down here, and this is the road from a different camera, I guess. I don't know what's going on here. Boom. Okay, it's illuminating, and you can see this is the road. Extremely brilliant. Extremely brilliant glow here. So something is pushing down extremely hard, but not in a lightning strike. It's pushing down in a region. All right, now let's keep going. Boom. Now, so we saw that that was a region, not a strike. Now, boom. Then we saw the little flaky stuff, and then we saw some more electrical activity showing up, and now, all right, here, I guess they're going to show it as a total event at the same time. So here he is seeing it like this and having the entire glow, not lightning. However, up there is lightning-ish coming down, smashing into this layer, which is now concussing, and he's seeing it from down here. Now, this is the layer above this layer that smashed, pushed these electrons up. And they could not be absorbed quick enough, so they trickled back down again. I have better shots at that. But let's just go forward with this. All right, they must be talking. Here we go. Whatever this is. Now, anything coming into our atmosphere explodes. That just hit a layer of the atmosphere. And they just overcharged that layer of the atmosphere, causing little red sprites. Now, sometimes they can be caused coming in, but not some of them. The red sprites, like, whoops, that's that one right there. These are coming up, smashing up. You see them? That's smashing up. That's up. And then it trickles back down. And these are the blue jets down below. They're really, really powerful. Then they hit the next layer, which makes another cascade, and then it hits the next layer, which, to me, that's what's going on there. And I have some pretty good evidence from the light experiments Rod Warren and I did. And these are the ones, like, see this? It doesn't take a brain surgeon to understand. See this glow? I tell you, every time you see a glow, 100%, 0 times do you see a glow that it's not related to an electron either banging into something or being released on its own. Because when it's banging into something, it's compressing and it's getting energetic. This is electrons going up, all at once. This up here says, whoa, 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 whoa. That's it. Done. Case closed. Go back. Too many. We're glowing, baby. They go back. Now, when that originally started to explode up here, down below, it glowed like you wouldn't believe. And the reason it glows like you wouldn't believe is because the only reason it can go up is because it's pushing from something to push off, like you push off from the ground. You can't push off into nothing. The only way you can get that is to have so many electrons layered down here that don't want them. And then you get these enormous glows down below because it's just a push off, like you're jumping off the ground and the ground is glowing. And they see it coming down from up above and they can't understand it. They think it's coming off of the earth. Let me see if I can find, well, here, let me see. I don't even know if it's on this video. But the Aurora Borealis and all that stuff, that's just lightning. I'm sorry, not lightning. It's just electrons coming through the fields of magnetic particles that are going as we scrub through them. It's just identical, 100% identical to what a generator does. And I've shown that because I take a little motor and I spin it backwards. A little electric motor, DC motor, you spin that in your hand and it will create electricity instead of putting electricity in. You spin it, it makes electricity go out. Same thing here. As the Earth spins, you're creating electricity, discharge, and that has to come back out and ends up funneling back into the Earth. And that's what creates our magnetic field, and it keeps all the really heavy-duty impact. I mean, I got so much on this that it's going to take me forever to show again. People don't like forever presentations, but you know, it kind of makes a big difference to what I was taught. All right, you saw that I say we're scrubbing through the atmosphere. It's building up charges. They're going up, they're coming down, they're doing all kinds of things. Normally it was lightning, it always went down to the Earth. Well, times they have it changed. Now, let's go a little deeper. All right, this is what's going on in our solar system. That's our sun. This is 4gifts.com. Now, the sun we know spins around in a circle. All right. We know we are on the arm of the Milky Way, going around in a circle of what we would call an accretion disk. I will show you that in a minute. We know that all the planets appear to circle the sun, and we know that we as a planet spin on our axis. All right, so we're all doing all kinds of things. So we're being rubbed through whatever's in front of us. It could get thicker, it could get thinner, it could do all kinds of things. We are also spinning. All right, so we're spinning into it as well. We're circling around and presenting it in different faces of our polar axis. All kinds of interactions, all kinds of things. Now, let's look at this as what's going on in the galaxy, because we are on an accretion disk of a galaxy, spinning around like this. And at one time, this could very well have been an accretion disk like this, just flat as a pancake. The whole thing would be basically flat and spinning like a big galaxy. And then everything condenses, because these are all scrubbing into particles that are out here. And as they hit them, they push them in, and it's concussing, it's crushing. Exactly what you will see in our Milky Way is what's happening here. These are crushing the particles in against the sun, illuminating the sun. And the sun has to get through all the stuff in front of it anyway. And it's always push to shove. You know what electron flood theory does. And I showed 1,000,000 times the red laser exploding. Absolutely exploding, causing unbelievable amounts of energy. Exactly what happens on our sun. You will see it right now. Now this is a fabulous shot. I don't know where I got this from, but wherever it was, I appreciate looking at it. Now, this is an eclipse of the sun. So the sun is behind here. The moon has eclipsed it, and we are photographing. You see these here? Those are the sunspots. You see the red, red, red? This is spinning this way. These are concussing into the oncoming stuff that's pushing it this way. As you can see, we're streaming through it. It's coming through it, and it has to come around, and then it comes and pinches back in. Same thing here. Comes around, pinches back in. And these are the poles. As it spins, we have the poles, same as we have on Earth. It's identical. Now, why don't we have any sunspots over here at this point in time? Because we are filming from here, and I believe these are literally, I got an idea, I think they're mountains. Because they stay in the same spot day after day after day, these sunspots. Why are they so much brighter? Why are they glowing like this? When I see that, that's concussion. That's concussion, that's concussion. Something's scrubbing harder in these spots. They're giving off more energy. That means there's more concussion, more glow. Case closed. Now, this is really interesting. And that's a solar eclipse. And you can see the interaction. It's going like crazy, and it's spinning. That's why so much more activity here than over here. This is sort of trailing off. This is fighting in. And it's really streaming off of here. Here it's sort of coming off, not, it's sort of swishing away like nicely. See it? Isn't that very cool? You know, if you take your time and you look at things, you can really look at how interactive that is. Urgh! And this guy says, yeah, have a nice day, see you later. I got to meet up with these guys. And then when they come off of there, look at them stream back violently. All right. All right. Remember, we are literally a ball of electrons spinning, circling, going forward, doing all of these gyrations and twisting on our axis as we are scrubbing through the particles that are in space and from the sun that are hitting us and from every other luminous body, because if you see it, something hit you, an electron hit you. If you see light, there's electrons. Electrons are hitting something there. All right, they're hitting you. You're seeing the particle coming at you as a particle. Now, so here we are somewhere here. This is basically a flat accretion disk, and it is getting crushed. You see these? They're literally wrenching. It's literally wrenching because what is it doing? It's spinning against the particles that are all out in space, pushing those arms back, crushing it. So not only are we spinning this way and spinning that way and twisting this way and doing all these gyrations, we're also going forward into what might be darker or denser particles. It would be more light, and they would cause more interaction, more particle exchanges, more luminosity, more climate change, more red sprites. That's what I'm seeing. And they're everywhere. There's a bazillion of these. That's just our our galaxy. And there's millions, well, probably more than that, I don't know, galaxies in our solar system. There's just so many things going on. It's so hard. And wait till I show you you're going to see this and flip your mind out. Because I've always said, everything to me looks like it could be literally particles that I see on a micro scale, on a macro scale, which would mean these were literally molecules. And in the molecular range, they're attaching to certain things and creating the soup of everything. Because everything, if you take this thing here, it's a rock. Well, it's actually a goose head, but it's a rock. Now, that can get warm, that can get cold. When it's warm, what does it mean? It means it has more electrons. It means there's more glow going on in there. All right, so the electrons leave, it gets cold. Where do you see what they did when they took a 3D of the universe? All right, you might want to sit down. This is the SDSS, releases largest 3D map of the universe ever created. These are the zones of influence. Hold on, here it is. These are the zones of influence that overlap everybody else's zone of influence. And these are molecular bonds, and these are the nucleuses. And the nucleuses are made up of bazillions of electron particles, and they congeal into the center. And then they overlap, making up molecules. And that is identical to the electron flood theory, because inside of here you have all kind of extra electrons going on, but it's sort of an electron soup, but the core dictates the range of influence. Do you know a hydrogen atom has a 21 centimeter range? Let me show you that. Don't forget, that's the zone of influence, and I'm talking about atomic, molecular, deep as you get. All right, I said that electrons, well, photons, which are back-to-back electrons. Each one of these is an electron. One this way and one that way makes it a photon, basically neutral. And an electron is half of that, basically half of that. All right. Now, I've explained that pretty well, I hope. Now, when I say it controls a region around it, it's a particle, but it's way in the center, and it has a region of influence, which is literally gigantic. Now, how can I say that? Because of the hydrogen line. 21 centimeter line. When you take the hydrogen atom, which is much bigger than this. This hydrogen atom is 1,837 electrons, so it's about 900 times bigger than this. However, when that goes through, it controls a region around itself of 21 centimeters. All right? It's called the spin-flip transition. As it moves, it flips the particles that are up to 21 centimeters around it into a different polarity. It changes it from a 1 to a 0, a 0 to a 1, whatever. All right, it's extremely easy to understand once you understand that the Earth is plowing through particles that are crashing into it, into our atmosphere, flattening the actual layers of the atmosphere. That gives us a base fundamental frequency of 7.83 hertz. That's this one way down in the lowest one. The second level is the 14 hertz, which adds 6.5. Then the next level is the 20 hertz, and that adds another 6.5. And then it goes up 6.5 after that, each layer, and those are push to shove, push to shove, push to shove. During the day, you have what I forget what they call it, but it's diurnal, and there's day and night. So during the day, you have an impact here, and it trails off in the back. At night, it's just the opposite. You're back here at night. And that's because it's impacting, obviously, with all of the stuff that's in front of it. As we saw, it's spinning, it's going forward, it's doing all that stuff. Now, and you can see there's a whole bunch of other frequencies here. 7.83 is the extreme, and these are extremely low frequencies. And they're very long frequencies. That's why, if you ever see the Tsar bomb, put it in the Tsar bomb, and see that go off, you'll see a layer in the atmosphere vaporize, and then another layer vaporize, and then another layer vaporize. And that's the particles going and smashing into these layers. And there's 7 layers, and those 7 layers, I believe, are these 7 layers right here. And these create frequencies within that cavity zone that make molecules do what they do. I mean, it sounds crazy, but well, let me put it this way. These don't make the molecules happen within these cavities. These create frequencies that make the electrons shake in such a manner as that they can collect in these ways within these different frequencies, because that's all it is these are all different frequencies when they attach to each other. That's why they give off different colors of light, and when they bond and all that. I think I showed you how the 3D of the universe looks, and they're, as far as I can say, it's as above so below. I haven't found anything that was written in the ancient text that doesn't seem wrong to me now. It's very crazy, but it seems they knew what they were talking about at one point in time, long ago.